As of 2026, there are about 14,000 active satellites orbiting Earth, and that number is growing fast. They watch the weather, connect the world, help scientists explore the universe, and even keep countries safe. As of 2026, there are about 14,000 active satellites orbiting Earth, and that number is growing. EARS are messengers in space. They watch the weather, connect the world, help scientists explore the universe, and even keep countries safe. But how did these metal marvels get up there? Who built the first ones? What kinds are there? And what does their future hold for us? Join us on an incredible journey, from a tiny beeping ball in 1957 to the mega constellations lighting up our skies today. This is the story of satellites, our silent guardians in the sky. The space race ignites as rockets soar. Sputnik, the first satellite, shocks the world. Newspapers scream of the competition. A timeline marks humanity's giant leap.
In the 1950s, the space race ignited. The Soviets launched Sputnik, shocking the world. Newspapers screamed the headlines. A new era of exploration had begun.
The dream started on paper. In 1945, British scientist Arthur C. Clarke wrote a famous article, Imagine satellite fractured beam TV and radio signals around the world. Then, on October 4, 1957, the Soviet Union shocked the world. They launched Sputnik 1. Just months later, in 1958, the United States launched Explorer 1, their first satellite. It discovered the Van Allen radiation belts that protect us from dangerous space particles.
The race was on. In 1960, NASA launched TIROS-1, the first successful weather satellite.
Lift off! We have a good orbit!
Suddenly, we could see hurricanes forming from space.
In 1962 came Telstar 1, the first satellite to relay live TV across the Atlantic. Millions watched the first transatlantic TV broadcast. Syncom 3 became the first geostationary. By the 1970s, countries like China joined in. Satellites help with everything from mapping farms to disaster relief. Today, private companies like SpaceX launch dozens at a time. Not all satellites are the same. They're like specialized tools in a giant toolbox in space. Communication satellites are the talkers. They bounce phone calls, TV shows, and internet signals around the globe. Weather satellites are our storm watchers. They track cyclones, measure temperature, and warn us before disasters strike, saving thousands of lives every year. Scientific and astronomical satellites explore the unknown. Hubble and others peer deep into space, discovering new planets and galaxies. And yes, some are military or reconnaissance satellites, keeping an eye on the world for security. Fun fact, one satellite can photograph the entire in the Bay of Bengal uses that data. Space isn't empty, it has invisible highways called orbits. Satellites stay up there because gravity pulls them in a perfect curve. It's like swinging a ball on a string. The string is gravity. Low Earth orbit, from 160 to 2,000 kilometers up. Satellites here zip around Earth at rate for men and sharp photos, but they move so fast you need many of them to cover the whole planet. Low Earth orbit, from 160 to 2,000 kilometers up. Satellites here zip around Earth at rate for men and sharp photos, but they move so fast you need many of them to cover the whole planet. Medium Earth orbit, about 2,000 to 36,000 kilometers. This is where GPS satellites live, taking 12 hours per orbit for constant global coverage. Geostationary orbit, exactly 35,786 kilometers above the equator. Satellites here orbit. From the ground, they look like they're hanging still in the phone signal. Some even use polar or sun-synchronous orbits to scan the whole planet every day. The right orbit makes the magic happen. Precision assembly and rigorous testing ensure flawless performance. Inside, advanced components work in perfect harmony, and reusability brings the future of spaceflight. Building a satellite is like packing a super smart robot for a long space trip. First, powerful rockets blast them into orbit. Companies like SpaceX now reuse cheaper and more common. Solar panels unfold like giant wings to catch sunlight and make electricity. Batteries store power for when Earth blocks the sun. Antennas and transponders are the talk boxes. A ground station beams a signal up, the uplink. The satellite catches it, amplifies it, changes the frequency so it doesn't back down, the downlink. Sensors and cameras collect data, pictures, temperature, signals. This data is processed in real time, enabling precise monitoring and analysis. Computers and propulsion keep everything pointed the right way and make tiny adjustments so the satellite doesn't drift. Ground control to all nodes, status check.
All nodes active, processing data.
Copy. Deploy updates to network.
Updates deployed. Relaying results.
Think of a satellite as a super tall cell tower in space, but moving at 28,000 kmh. The future is bright and busy. Companies like SpaceX already have over 10,000 Starlink satellites. Plans for even more mega constellations promise internet everywhere on Earth. New tech is coming fast. Laser communication, artificial intelligence running satellites on their own, tiny CubeSats anyone can build, and even data centers in space. But there are challenges too. More satellites mean more space junk. Saranthus varofens stated meeting low in 96. We'll also see better climate monitoring, disaster prediction, and maybe even satellites helping us explore the Moon and Mars.
From orbit, our world is a tapestry of life. Satellite technology connects us all. It guides our way and feeds our future. Look up and see the possibilities.
From a single beeping satellite in 1957 to a sky full of thousands today, satellites have changed everything. They connect us, protect us, and help us understand our beautiful planet.
From orbit, our world is a tapestry of life. Satellite technology connects us all. It guides our way and feeds our future. Look up and see the possibilities.
Next time you check the weather, use GPS, or watch TV, remember the silent guardians high above, working tirelessly so we can live better lives on the ground. The sky is no longer the limit. Thanks to satellites, our future is written in the stars. This script is simple and easy for everyone to understand. It's packed with real engaging facts, and it uses stories and visuals to evoke wonder. It's the perfect foundation for a 1-hour documentary. High above us, thousands of silent machines are watching, guiding, and connecting our entire world. But what exactly are they? And why do they matter to every single one of us?